start off with question 17. Alright, so what I would have said previously is that when you get cosecant theta, and once again, if you forget what you're looking for, you can always just go to page 13 of your notes. 13. There we are. And cosecant is 1 over sine A. Just always remember that you're capable of doing that, alright? So cosecant is 1 over sine theta, and square both sides. So cosecant squared theta is 1 over sine squared theta. Okay. So what I'm going to do first and foremost, I'm going to change this into 1 over sine squared theta. Alright. I'm also going to convert the tan squared. I'm going to convert the tan squared into, remember, tan theta equals sine theta over cos theta. So what I can do here is I can square both sides and just say it's sine squared theta over cos squared theta. And this can be minus sine squared theta. Okay. And once again, all that equals tan squared theta on the right hand side. So I'm going to see what happens here. Well, I'm going to multiply this one by this one. And we can see that when I was to multiply the two of them, the sine squared theta will cancel off, leaving behind 1 over cos squared theta. I'm happy enough with that. Next thing we're looking at is 1 over sine squared theta multiplied by minus sine squared theta. And once again, the sine squared thetas would cancel off, just leaving minus 1. Okay. Now, I'm looking at the other side and going, how do I get tan squared theta from here? Well, if I go back to my tables, and in my tables, see this here, sec squared A equals 1 plus tan squared A. And what is, so in this case, 1 over cos squared theta is actually sec squared theta. Minus 1 equals tan squared theta. And then change sec squared theta into 1 plus tan squared theta. Take away 1, and that equals tan squared theta. And then the ones cancel, you're just left with tan squared theta equals tan squared theta. Right, all day long, that's handy enough, right? So that's question 17. But sorry, that's not handy. It's difficult, alright? I've been at this a while. I should be good at them, you'd hope. Now, use the sine rule or the cosine rule to prove the following identities. Well, the first thing I'm going to look at is I'll do question 20. So what am I on? 17 followed by 20 at the moment. 20 looks harder. Now, here's what I'm going to do at the moment, right? I'm looking at all this here. BC cos A, CA cos B. I'm going to write down two variants of the cosine rule. I'm going to write A squared equals B squared plus C squared minus 2BC cos A. Now, the reason why I started off this way is I identified the cos A, and to get the cos A, this part here, I need to lead with the A over here. Next one, I'm looking at cos B. So to get a cos B, I need to lead with a small b. Okay, and then that will make that 2 AC cos B. AC being the same as CA. Now, what I'm going to do with both equations is I'm going to isolate, as you can see here, see the BC cos A, I'm going to isolate the BC cos A. See the CA cos B, I'm going to isolate the CA cos B in both equations. So, what I'm going to do is I'm going to move this to the left and this one to the right. So I'm going to end up with 2BC cos A equals B squared plus C squared, take away A squared. Next one we're going to do is the next one we are going to do is going to be 2 divided by 2 because I want it on its own. So it's going to be B squared plus C squared minus A squared all over 2. Likewise, I'm going to do the same with CA cos B. Move it. It's going to be exactly the same thing. So it's going to be, except just the letters are going to be in a different order. Okay. So essentially, you can just interchange big A with small a, and you can interchange You can just interchange the letters if you want, but that might be more confusing, if anything, for some people. So we'll just move everything over. So I'm just going to get 2ac cos b equals a squared plus c squared take away b squared. Divide it out, so I'm going to get ac cos b, same thing as ca cos b, equals a squared plus c squared minus b squared all over 2. And then I'm going to join the two of those parts together. So we're going to get a b squared plus c squared minus a squared over 2, which represents the bc cos a. Now I'm going to get the ca cos b, which is represented by a squared c squared minus b squared all over 2. And my hope is that the answer equals c squared. Let's find out. Well, the b squareds cancel, the a squareds cancel, and I end up with 2c squared over 2 equal to c squared, and then c squared equals c squared, and we're done. That's what we're asked to prove. So that's 17 and 20. Now, 21 actually, I know it doesn't look it, but 21 looks difficult because it's lacking parts, right? So I'm going to go for b cos a and a cos b. So I'm going to write down the formula that starts with a. The reason I wrote that is so that I get the bc cos a, or the essentially what I want there is I want to keep the b and I want to keep the cos a, like so. And then on the other side, I'm going to have I want a b, so it's going to be b squared equals a squared plus c squared minus 2 ac cos b. And once again, I'm looking at this here, and I want to keep the a here. Now I'm just going to do the usual. I'm going to move everything to one side, so I'm going to get 2b, oh sorry, I'll use blue, 2bc cos a equals b squared plus c squared take away a squared. And I'm going to divide it by the parts I want. I want to keep the b cos a, so I'm going to divide by the 2c. I'm going to take out the 2c there, so it's going to be b cos a equals b squared plus c squared minus a squared all over 2c. Likewise, down here, you're going to do the exact same procedure. Now, some of you might be good at the interchange method, which means interchange small b with small a, and interchange big B with big A. Let's see if it works out nicely this time. So it's going to be small b changes to big A. Oh, sorry, small a. Big A changes to big B. B changes to small a. C changes the same. A changes to B. And then 2C, which would be stays the same. That's the interchange method. You can just say likewise. It depends what you want to do. You could just work through all the steps again if you wanted exactly the same thing. Now, I'm going to add b cos a. So b cos a plus a cos b should equal c. That's what we're trying to prove. So, essentially what I'm trying to prove here is that b squared plus c squared minus a squared all over 2c is exactly the same as that c over the other side. Now, b squareds cancel, a squareds cancel, we end up with 2c squared over 2c equals c, and then we know that basically c equals c, which is correct. Alright, that one done. So 70 and 20 and 21 are done. 20 and 21. Now, no doubt which one you want to see here. It's probably question 24, purely because the question 24 has a fraction in it. God forbid, a fraction. Or, it's actually 24 is nearly the same question we did last time. 24 is the more difficult one. Let's do 24. Now, 24. Now, A squared. Nope, I'm not using. So first of all, I'm going to identify which variant of the cosine rule I need. I need cos B and cos C. Oh, don't get me started on variants, lads. Oh, I hate variants. Now, B squared equals A squared plus C squared. I was going to say this for prosperity's sake. Daily, wake up. Okay. Now, what else are we going to do here? Oh, yeah, it's AC. Cos B. Awesome. There's a cos C this time, so I'm going to use C squared equals A squared plus B squared minus AB cos C. I'm going to isolate C cos B, C cos B, and B cos C. Alright. I haven't done a couple of times already, so it's going to be 2. Why do we always use 2AC cos B equals A squared plus C squared minus B squared. Then we're going to get C cos B equals. At this stage, you should probably be trying them by yourself. So if you're being lazy, stop it. Press pause. Try to finish it off yourself. Right? Can't be doing everything for you. Now, what are we doing next? Over 2A. Is that correct? 2A? Yeah, why not 2A? Now, C cos B. Now remember, your assignments aren't complete until you post up all of this on PDF onto the Google Classroom assignment, right? Just to make sure that you're actually doing your work. Now, I'm going to do an interchange because I'm being lazy. You can work through the exact same process if you want. In this case, it's B to C, so capital B and capital C are interchangeable, and small b and small c are interchangeable. So if I do likewise, what I should get here is I should get B cos C equals A squared plus B squared, and change that B into a C all over 2A. So there's your interchange right there. Now take one away from the other. So we're going to do C cos B minus B cos C. So we're going to do blue, take away red. Take away red. And this will equal, what will this equal? This should equal C squared minus B squared all over A. Right. So they have the same denominator both two ways. This minus makes that a minus A squared, a minus B squared, and a plus C squared. The A's cancel. The B's can no, the B's don't cancel. So you actually get 2C squared minus 2B squared all over 2A, which is exactly what we want. Divide top and bottom by 2, and you should get what's on the right hand side there. C squared minus B squared over A equals C squared all over A. Happy days, alright? So that's. Now, what do I have now? That's 24. 17, 20, 21, and 24. 17, 20, 21, 24. Alright, let's try 25. Now, I tend to take the more complicated side, so I'm going to write down sine A and sine B. I'm going to write down the sine A over sine A, B over sine B. That's the sine rule in a nutshell. Right? So, what we want to do is we sort of want to get rid of the sine A, the sine B, and the other sine B. I'm going to break this up. So I'm going to break this up into sine A over sine B minus sine B over sine B. In the same way, if you will, 3 minus 1 over 2 is the same thing as 3 halves minus 1 half. Same thing. Okay? So, just split the denominator. Now, we know that sine B divided by sine B is 1. Now, it's sine A over sine B. Now, that's exactly what I'm going to do. I'm going to sine A over sine B. I'm going to bring that sine A to the top right and that to the top left. And I'm going to get A over B equals sine A over sine B. And that makes my life easy because it's A minus B, take away 1, A minus B over B. Now, if I give this a common denominator, I turn 1 into B over B, you find that we have the same answer on both sides. Bada bing, bada boom, you're done. Simple, right, lads? No, it's not simple. You just gotta practice them, and you're gonna go down completely different routes than I do. So it's about systematically trying to get rid of what I had to get rid of all the sine A's, sine B's, because on the right hand side there is no sine A, sine B, so I had to get rid of them. Okay, that's a cosine root proof again. Where's the sine rules? I must go back and look because there isn't that many sine rules, is there?